All right, so we brought up confidence intervals. Now let's talk about what it actually means to have a confidence interval. So let's interpret it. So a 1 minus alpha times 100 confidence interval indicates that this value, pardon me, of all simple random samples of size n from the population whose parameters unknown will result in an interval that contains the parameter. That's why we have to have our point estimate and our margin of error. Our margin of error enables us to make sure that this interval is going to contain the parameter. In other words, we are, insert level, 95% confident, 90% confident, right? That the population proportion is between whatever the lower bound is and the upper bound. That's how this statement is what we are always going to write at the end of these. All right, so we are certain amount confident. This is a confidence interval, so we use the word confident. All right, that's how that works. All right, so when the Gallup organization conducted a poll, introduced an example 1 where that 45.1, remember we figured out the proportion, and we're just changing it to a percentage here. Of those surveyed, consider the amount of federal income tax is too high. Gallup reported its survey methodology as follows. Results are based on telephone interviews with a random sample of 1,015 national adults, aged 18 or older. For results based on the total sample, one can say with 95% confidence that the maximum margin of sampling error is 4 percentage points. All right? So if I'm looking at this at 4 percentage points, margin of error is a capital E. So with this margin of error here, 0.04, because it says the word percentage, so I have to change that to a decimal. All right? Now, we want to determine and interpret the confidence interval of the proportion of Americans aged 18 and older who believe the amount of federal income taxes they have to pay is too high. So, first thing we're going to look at is the point estimate. Our point estimate is what? 0.451. Yes, that's our p hat. That's our point estimate. I'm going to write, which is p hat is equal to 0.451. And then I have my margin of error. And what did we determine our margin of error to be? 0.04. Yes, if it had just said 4 points, then it would just be straight up 4. But the fact that it uses the word percentage, that's why you have to change it to a decimal. All right. Sometimes it just says 4 points. We'll see some examples like that. And sometimes it says percentage. So just make sure you're paying attention to the writing. All right. So our confidence interval here is going to be p hat plus or minus the margin of error. So I have for the lower bound, we're going to have my p hat, which is 0.451 minus the margin of error of 0.04. And what do you get for that? 0.411. No. 0.451 minus 0.04. Oh, yeah. Because the one I was looking at okay. Tune in, Bradley. This is 2 decimal places. This is 3 decimal places. So this is minus 0.04. So the 1 drops down, then you have a 1 and then a 4. Okay. See? That's why we check ourselves. That's why I usually pull my calculator out. I was trying to do that one in my head. Sometimes you got to check yourself before you wreck yourself, right? I hear that. All right, so 0.451. The upper bound means on the other side. So this is really my p hat plus my e minus my margin of error. That's kind of what this is saying. That's how you get a lower bound. You're taking the margin of error in the other direction. The upper bound is the margin of error up high. So I'm going to add 0.04, And that's where I get 0.491. So my confidence interval, so we're going to write this statement that we have up here. We are 95% confident, because that's what it tells us, 95% confident that, and then we're going to put our words in there, that the proportion of Americans age 18 and older who believe the amount of federal income tax they have to pay is too high. That's what those words are. That, oh, that's a lot. Let's make this happen. We are 95% confident that the proportion of Americans, I got a lot of writing to do in here in this small space. The proportion of Americans 18 and older who believe that the amount of federal income tax they have to pay is too high, who believe I'm going to abbreviate, amount of Fed income tax is too high, is between 0.411 and 0.491. So what this is saying is, based on my point estimate, based on my sample, on the information I've given, I am now saying between 0.411 and 0.491, I am 95% confident that the parameter is in there. That's what we're saying. All right. So that the real, based on the whole population, is going to fit. I'm 95% confident that based on the whole population, that is my interval of where I'm working with it. Right? So statistics, I mean, unless you're actually dealing with a population, which is so rare, there's no way you're going to get every single American 18 and older to weigh in on this. So we have to give ourselves a little bit of leeway in statistics. And that's why we say we're 95% confident. And that's where these confidence intervals come in. All right? Okay. Now we are going to actually make some confidence intervals here. All right? So this is what this is going to look like. Suppose that a simple random sample size N is taken from a population or data that result from a randomized experiment. A confidence interval for P is given by the following quantities here, all right? So P, remember, that's my population. However, we are looking at our sample. So we're writing this as P hat minus this critical value, and it's given as Z alpha divided by 2 times the square root of P hat 1 minus P hat all over N. And at the upper bound, remember, we're looking at our upper and our lower bound. This is the same thing as the margin of error. Ooh, I'm going to scroll this down just a little bit. Do you see what's going down right here? This is P hat minus the margin of error, which is what we did. So what do you think the upper bound is going to be? Yes, literally this exact same thing, except with the plus sign. Cool, right? Yeah, I think so too. So this is P hat plus this Z alpha divided by 2, which is a critical value, the square root of P hat 1 minus P hat all over N. So again, this piece with the radical and the critical value, that is my margin of error. It's the upper bound, so I'm adding. The lower bound, I am subtracting. That's what you can see there. All right. And then here's another note. It must be the case that it is normal. Basically, that's what that means, right? It must be the case that NP times 1 minus P is greater than or equal to 10, and the sample is less than 5% of the population. That's where the lowercase n and the uppercase n come from, right? This just simply means normal. And we've already worked with that, so we already know that. I'm going to put criteria. Now, you may look at these formulas and you're like, what are you doing right now? Guess what? Welcome to your best day ever. We are going to let StatCrunch do these calculations. StatCrunch is going to do the calculations for us, but I want you to know these concepts. This is still p hat plus or minus the margin of error. That's the concept you need to get down pat. Then we're just going to use StatCrunch so that we don't have to use these great big formulas. It's going to plug that out for us. But the concept, you really got to get that concept. All right? Okay, so margin of error that we're looking at, E for margin of error is that Z alpha divided by 2, P hat 1 minus P hat divided by N. That's what you're getting out of that deal. All right? All right, so this is just the margin of error, so it's that exact same thing that I want to make sure you get. This is p hat plus or minus that margin of error. This is the margin of error that shows up in those formulas. And we talked about this before. So on the previous example, we said, oh, within 2 standard deviations at 1.96. Well, that was only at 95. Well, what if I wanted to do something different? No problem. The critical value, that's where that 1.96, this critical value part, it's just plus or minus this critical value. It's still P plus or minus these margins of error, and it just depends on how confident you want to be. So whatever your level of confidence is, that level of confidence is what you're going to work with and add or subtract to make it within that margin of error. Okay, so the concept, P hat's in the middle, and I'm giving myself some cushion with this margin of error. Depending on how confident I am, depends on how much cushion I am giving with that margin of error. Okay.